What I'm going to do here is to show you pulse width modulation from an Arduino to connect to motors and to control the speed of some motors. So what I've got is an Arduino which is connected by these wires here to an L298 underneath here. An L298 is a motor driver which allows the current to be amplified from the Arduino. It allows it to be large enough to drive some DC motors. The voltage for the motors is going to come from this battery pack here. So the Arduino is going to send signals through these wires to the L298 motor driver, which is then connected to these two DC motors. They're just connected in parallel, so they'll both move together. It's part of the four-wheel drive robot. So looking at the program, what we've got is we've got the two pins. Pins 4 and pins 5 are connected from the Arduino to the L298, just to one side of that, of the motor driver. Pin 4 is used to control the direction of the motors. So that's why in the setup I've got pin 4 set as an output. Now what I'm going to use is pulse width modulation on pin 5. So in setup you don't have to actually tell it that it's an output for some reason. Not quite sure why. It doesn't do it any harm if you do put it in as an output, but you don't have to. Okay, now in the main loop I've set digital 4 to be low. That means that the motors are going to go in a particular direction, and analog right is the pulse width modulation library in the Arduino. So analog right to pin 5, and then any number between 0 and 255. 255 is its maximum speed, 0 is completely off. Now I've set it to be 100 just to show you what happens. Now in this particular robot, these motors aren't very efficient, so you would expect at 100 them to be moving, but they're not, because there's quite a lot of static friction in here. You might be able to hear an annoying whine. Now that whine is the sound of the pulse width modulation and the voltage pulsing in the coils of the DC motors very quickly. And you've probably heard this on electric buses, electric trams, electric trains. You can hear that whine. Now these are actually trying to turn. If I give it a helping hand, wrong way, there we go. We do actually get a bit of motion there, so might be able to get both of them turning. Yeah, so it's not very reliable, and they're very easy to stop, and once you stop they won't start again, so not very good. Small amount of voltage there. So what I'm going to do is just change this value of 100 to 150 and then re-upload. So I've uploaded that, and you can hear that the value has changed, and yeah, there we go. So we've just got it started. It's actually going backwards. Fairly slow, value of 150. Hard to calibrate really, but 150 seems to have got it moving. Okay, so what I'm going to do is increase that pulse width modulation value. Let's try 200 and re-upload. So it's compiling it. Once it's re-uploaded, it should start again. You can probably hear that they are moving faster. And then if I had it at full whack, so let's put in a value of 255. 255 there. Re-upload it. It'll take a few seconds to upload. Re-upload. And there you go, it's going at full speed. So you can actually modulate the speed of the motor, probably in values between around about 150 up to 255. Anything lower than 100 and the motor is just going to probably be stationary. But every motor's different, so it's worth just checking, and you know, it's going to be very non-linear below 100 for this particular robot, but some motors are more efficient than others.